Okay, so now we can actually start applying our logs to actual equations that'll help us be able to solve. So I'm going to do this example right here, a simpler example, and I'll have one that is more of an applied situation later. So we have an equation here, an exponential equation. 11 to the 5 minus x equals 8, okay? And normally, what we do with like linear functions and quadratics and stuff is we try and get the x by itself. Unfortunately, using all of our methods before learning about logarithms, we would not be able to do that. We would be really stuck because we had no way to move this x down in front. We would not be able to separate it from the 11. Fortunately, we have logs for doing that. So we're going to use those. Okay, so you have this situation. When you have a variable in the exponent, okay, when you have a variable in the exponent, you should be using a logarithm to move it down. Okay, so our strategy, what you need to be thinking here is if there's something in the exponent, you need to use a logarithm to move it down. Okay, so in this case, so generally you're going to use either the common log base 10, or the natural log. We will use the natural log when we have an e as our base. Okay, in this case it's an 11, it's not an e, so we're not going to use the natural log, we will use the common log. Okay, so to solve this, we need to use that logarithm. Logarithms are just like any other function. So like if we square one thing, we have to square the other thing, same thing with logs. Okay, if we take the log of one side, we need to take the log of the other. Okay, so to move this down, I'm going to take the log of both sides. Okay, so I'm going to say that this is log of 11 to the 5 minus x equals, okay, so I took the log of this whole side, now I'm going to take the log of this whole side, equals log 8. Okay, you can write the parentheses just to be careful, you don't always have to. Okay, so I get to here. Now what I'm going to do is I'm going to reference that first property that allows me to move my exponent down in front. Okay, in this case, my whole exponent is 5 minus x, so I'm going to move 5 minus x down in front. So this becomes 5 minus x log 11 equals log 8. Okay, so now once we get to here, x is now on the bottom, or well, x is not in an exponent, so what we can do now is just kind of basically our algebra. And we are now at this point trying to isolate x and get it by itself. So we're going to start moving everything over to the other side, and we're going to do that in ways that you have done your whole mathematical career. Okay? So once we get to here, we have 5 minus x times log 11. So we can't really do anything about the 5 at this point, so we need to divide by log 11 first. So we are going to divide log 11 from both sides. So we're going to get 5 minus x equals log of 8 over log 11. Okay, so we have divided by 11. Once we get to here, we still want to get the x by itself, so we're going to subtract 5 from both sides. So we get negative x equals log 8 over log 11 minus 5. Notice that at any point you could choose to simplify this on your calculator. You could type in what is log 8, what is log 11, divide them, and get a long decimal. I'm not going to do that until the very end because it makes it less accurate if you do it already. Now I have a negative x, which means I need to multiply both sides by a negative 1. So I'm just going to flip the signs of everything. So this becomes x. I'm going to move the 5 out in front. This becomes a positive and a negative over here. I guess I could have just kept it up there. But anyway, so I'm going to move the 5 over here because I like to subtract things last. Minus log 8 over log 11. Okay, once we get to here, now you can simplify. So on the example, on the notes, I've written out the steps for all of this. This becomes 5 minus log of 8 is 0.90309. Log 11 is 1.04139. If I divide those things, I get 5 minus 0.86719. And And finally, if I just do this 5 minus whatever here, I'm going to get 4.13281, okay? You don't have to show every single step like this. You can literally just type it in your calculator, 5 minus parentheses log of 8 divided by log of 11, parentheses, and you would go straight from here to here, okay? So you don't have to show these intermediate steps. It's just, that was for me so that you guys could see every single point along the way. Okay, so this is how you would solve an exponential equation. So this, remember that this is x, so the solution to this equation up here is x equals 4.13281, okay? So we use our log properties, and basically all we're doing once we use our log properties is just trying to isolate for x. We use the log properties to isolate for x. So this is our problem. Hopefully you can follow through it and then complete the problems that are below.